Welcome students. Let us consider a two variable Hessian differential equation m dx plus n dy which is not exact. Exact means from our earlier video we know that del m del y is equal to del n del x. If this is not equal to, then we say that the equation is not exact. Okay, but when an equation is not exact, it is certain that we can make it exact by multiplying some function of x and y. Such a multiplier is called an integrating factor. Okay, and we write if for integrating factor. Okay, if means integrating factor. So there is a theorem that which says that the differential equation m dx plus n dy equal to 0 possess an infinite number of integrating factor. Okay, that means although the equation m dx plus n dy always has integrating factor, there is no general method of finding them. But here we have some rule by which we can get one particular integrating factor, but it should be remembered that there are infinite number of integrating factors for an equation of the form m dx plus n dy. Okay, so here you can see that if f of mu f of b is an arbitrary function of b, then if we multiply it by any constant, that will also be an integrating factor. So it follows that there are infinite number of integrating factors. Okay, so there are, although an equation of the form m dx plus n dy equal to 0 always has an integrating factor, but there is no general method of finding them. But we can use some rules by which we can find the integrating factor. So first rule is that by infection. So in infection, often an integrating factor of the given equation can be found out by inspection as explained below. Okay, that means by rearranging the terms of a given equation or by dividing a suitable function of x and y. Okay, so sometimes we will rearrange the terms and we will divide the divide by a suitable function. Okay, function of x and y. The equation thus obtained will contain several parts integrable easily. Okay, so here are some list of exact differential equation, exact differential form which you should remember carefully. Okay, suppose x dy, you get somewhere x dy minus y dx by x square. So what we can write in differential form, d of y by x. Okay, so this is, you can say that derivative of u by v, na? That is v square, v into derivative of u minus u into derivative of v. So this kind of thing. So x dy minus y dx, we can write d of y by x, because x square is below in the denominator, so we can write d of y by x. Similarly, we can write d of x by y. Okay, that means y dx minus x dy by y square. Similarly, d of y square by x. So this is like x square below, and x derivative of y square means 2y dy minus y square will be dy and derivative of x dx. Okay, similarly d of x square by y, so y square below, twice y x dx minus x square dy. So similarly you just remember all these things. Okay, here you just remember log of xy. Okay, so here what you see, that log of so derivative of log x means what, 1 by x, na? So 1 by xy is there. Now you have to again apply the derivative over xy. So this is like x dy plus y dx. So ultimately you get x dy plus y dx by xy. So you can write d of log of xy, right? So that is d of xy is x dy plus y dx. Okay, so those who are not studied well in your class 12 this type of formulas, just you have a look on the list, you get all the differential form. Okay, so just remember carefully and practice carefully. Okay, see, solve this equation, differential equation. Here is what, y dx minus x dy. So y dx minus x dy is like d of this kind of form. minus form is there, minus form is there, then here is minus form is there, so minus form will be used. Now according to the question we have to decide that how we will solve it. So y dx minus x dy, so y first, that means we have to divide by y square. Sorry, you can divide by x square also. See, here is x square is there. Okay, who will determine that how we can divide? See, x square sin y dy. So if we want to free this y variable here, so we have to divide by x square. If we divide by x square, then this term will be sin y dy, this term will be 1 plus x square by x square, and this term will be y dx minus x dy by x square. Okay, so if we take minus common, what we can write? D of y by x, and that will be 1 by x square plus 1 dx, then this will be sin y dy. Now again you just integrate, what you get? Minus y by x plus x, 1 by x square dx is minus 1 by x, sin y integration is minus cos y equal to c. Okay, so this is your answer, right? So solve the second one, y of this dx equal to e power x dy. See, here is dx dx, this term free, so we need to divide by, okay, here is e power x, here is 2x y square dx plus y e to the power x dx minus e to the power x dy. Now if we divide by here y square, okay, if we divide here by y square, what we get? Twice x dx plus the whole term divided by y square. So now this term can be written as d of e power x by y. Understood? So by practicing you will be able to do such type of differential form. Okay, and also you have that confident, you will have that confidence to do the problems, right? So you need to practice lots. Okay, so after integrating, what you get? X square plus e power x y equal to c. Okay, so do these problems. Here is exercise 2f, so do this. Next we'll move on to rule 2. Okay, so here, if the given equation m dx plus n dy is homogeneous on m and n. Already I mentioned what do you mean by homogeneous function. That means m of xy, so each term will have the same power, right? So and mx plus ny is not equal to 0. Okay, mx plus ny is not equal to 0, then 1 by mx plus ny is an integrating factor. So we go on to a problem. Okay, suppose this problem, here m is this, n is this. Okay, first you check that this equation is not exact. Okay, first you calculate del m del y, then calculate del n del x, and check that these two are not equal to, because if they are equal, then our differential equation is exact, and we will do like integration of m dx keeping y constant plus integration of those terms of, will integrate those terms of n which do not contain x, right, plus equal to integrating equal to c. So the equation is not exact. Here also we calculate mx plus ny, which is x square y square not equal to 0. So our, according to our given rule, the integrating factor of 1 will be 1 by mx plus ny, that is 1 by x square y square. So so this, the left hand side can be written as what? D. So we have to, next what we need to know, with that multiply 1 by this integrating factor. Okay, multiplying 1 by integrating factor. So after that what we get? 1 by y minus 2 by x dx minus x by y square minus 3 by y whole into dy equal to 0. So which is exact, where solution is what? If you integrate, what will be solution? See, this is what treating. Now this is exact, na? Now this equation becomes, after multiplying by the integrating factor, the equation becomes exact, right? Which is exact. So now we will do the method integrating m dx treating y constant plus integrating only on those function which do not contain any x, right? So here is already minus is there, so minus 3 by y minus minus plus 3 by y, and here will be 1 by y minus 2 by x whole into dx, right? So this will be right x by y minus 2 log x plus 3 log y equal to log c. So what is your final answer? Y square equal to cx square e power minus x by y, where c is an arbitrary constant, right? You understood? That means first I just recap once again. A problem is given. First you find out m, then find out n, then find out del m del y and del n del x. You just check whether these are equal or not equal. Suppose it is equal, then then the given differential equation is exact, and using our previous rule, that is integration of m dx treating y constant plus integration over those terms of n which do not contain x, okay, equal to c. That is our final answer. Suppose this is not exact, then we have to need some others formulas, okay, right? We can use by inspection method, or either we can use this method mx plus ny, and if this is not equal to 0, then the integrating factor will be 1 by mx plus ny, right? Then after multiplying this, after multiplying the given differential equation by this, we get the differential equation which is exact. Now since this is exact, we can use this this method, like integration of m dx treating y constant plus integration of n which only which do not contain x, right, equal to 0. So using this you will just solve the example 2, okay. Next rule is that suppose m dx plus n dy equal to 0 is of the form, okay, form is some function of xy into y dx. We can separate the y only, and some function of xy plus x dy, right, equal to 0. That means dx with y and dy with x, okay. This is we can separate, and any function of xy, right. Then 1 by mx minus ny will be an integrating factor of m dx plus n dy equal to 0, provided mx minus ny not equal to 0, right? So just do this problem. Here m is so the problem is itself given cos xy x some function of xy, some function of xy, y dx and x dy. Then m will be what? M will be including y also. Do not think that m will be after only bracket. No, m will be up with y, and n will be with x. Then the form is this. So we use next you calculate del m del y and del n del x, okay. You multiply by y, then calculate del m del y and del n del x, right? Then check that these are not exact. Next you calculate mx minus ny, and you get this is not equal to 0. So integrating factor is 1 by mx minus ny. That means 1 by this. So you need to multiply equation 1 by this integrating factor. What you get? This term. Now this is an exact differential equation, so you just integrate first function with treating y constant plus integration of n only those terms which do not contain x, okay, into dy, okay. So you get this value, right? So you just do some other problems, okay, and also this exercise 2g, okay, right? In our next lecture we will discuss about rule 4, right? Thank you. If you have any doubt, you may ask me.